handling both numpy.array and float inputs in a single Python function. Introduction. When writing Python functions that involve numerical operations, you may want your function to accept either a single float or a numpy array seamlessly. This is common when your logic depends on checking values against some threshold, but comparing arrays and floats directly in the same conditional often leads to errors. For example, consider a function that keeps dividing the input until it's below a certain threshold. For a float, stop when it's less than the threshold. For an array, stop when its maximum value is less than the threshold. The problem. Two main issues arise. Using max x on a float raises an error, since floats are not iterable. Using x threshold on an array returns a Boolean array, not a single Boolean, causing issues in conditions like while x threshold. A clean, efficient solution. Instead of overloading or vectorizing, use type checking combined with numpy functions for a unified approach. Step by step. Convert float to a numpy array. If input is a float, convert it to a one-element numpy array. Use np.max for condition. Always check np.max x threshold works for both arrays and single-element arrays. Perform vectorized operations, dividing the entire array by 2 efficiently. Code example. Explanation. Instance x float checks if the input is a float. Converting to an array allows the use of np.max, which works for both. The while loop condition uses the scalar np.max x to avoid ambiguity. Finally, the function returns a float if the input was scalar, preserving consistency. Benefits. Single function handles both input types. Efficient due to vectorized numpy operations. Clear, easy to read code. Conclusion. By using type checking and numpy's functions wisely, you can write Python functions that work elegantly with both floats and numpy arrays without complicated overloading or inefficient vectorization. This approach leads to cleaner, more maintainable code that efficiently leverages numpy's strengths.